Thank you, Chris. And thank you to all our speakers today. As we move into the discussion, I wanted to say how exciting that today, for the first time, the United States Geological Survey of Canada, and Geoscience Australia are using an agreed classification for mineral systems in the newly created Critical Minerals Mapping Initiative portal. This portal contains the largest public critical minerals in ores dataset in the world, with more than 7,300 samples from 60 countries. Don't forget to visit the portal. It's simple to remember, criticalminerals.org. Now, in the portal, there's not just amazing data that you can download as a CSV and use in your own tools, but in the portal, you'll find other interactive tools. They're found at the right top-hand side of the web page, identified as a little spanner. These tools are being developed in real time, and we're very keen to get your feedback. There is a provide feedback function to help us further develop this cutting-edge technology. Today, we heard about critical minerals, how to predict, identify, and estimate critical mineral resources. Our first question I'd like to direct to Andrew Heap. Andrew, what's your opinion? What is the response from industry to the detailed maps that are intended to lower exploration risk?
Thanks, Marina. I hope everyone can hear me okay. So I think in the presentation that I gave, it was quite obvious what's happening in the Australian situation with a number of companies taking up new ground on the basis of the maps that we've produced. And I showed two maps where that's happening, one at a broad regional scale and one at probably more of a local scale. But I think what we're seeing in Northern Australia on the basis of all the work that we've done between Mount Islington and Gret, we're seeing new companies come in and take up new ground and plus reinvigorate some of the existing tenements they had there because of the new information that we've provided. So that's really encouraging to see, because that's exactly what we want to have happen out of the work that we're doing. We want companies to make decisions, we want new ground to be explored, and we want new discoveries to be made. I think, and then there's the second one was the Julimar discovery, which referred to around Perth, Western Australia, which is to the northeast of the capital city there. And again, new information coming out. I think it's fantastic in this day and age that with all the exploration going on, that we can still find new discoveries, new, almost tier one discoveries in Australia. I'm sure it's going to be the case for the US and Canada as well, that, there's a huge amount of new information coming out, but new discoveries to be made too. And I think also another one we've seen is the new discovery of potash deposits in Australia. And I think that for us is a really rewarding result, because what we've actually managed to do is actually transform the industry. So it's gone from, we've broadened and diversified the number of critical minerals and commodities that have come out of Australia. And I think that establishing a new potash industry in Australia is something that we can be really proud of. So that was on the back of the mineral potential mapping that we did, the same sort of thing that the Julimar product. So look, I think we're seeing some really good stuff in Australia, and I'm sure there are equally as good things happening in the US and Canada as well.
Thank you, Andrew. Geneviève, would you like to comment as well on the Canadian aspect?
Yes, I would like to add to the fact that the critical minerals is in fact a whole social project. It's not just data, it's not just analysis, it's not just prospectivity. So what industry is looking for, it's an entire system, a social project that will improve access to the global supply chain. And in Canada, we have two main focus for critical minerals. One is to improve processing technology, of course, and that's not the role of the Geological Survey of Canada, but the second pillar is to improve access to the market. And this is where we play a major role. In particular, yes, we need to access this data that is available now in the portal, and we have to improve our capacity for analysis. And the communication aspect also shown by many presenters today, the importance to sharing the results with the industry to reduce the risk on mineral exploration. So on those facets, we play a very important role. And yeah, that would be our contribution to this social project.
That's a great point. Thank you for that. Tom from the USGS, the response from industry with these maps and tools. What would you like to comment?
I think it's actually a bit early to say just yet, because this now is really our first event, CMMI event. So I think it's early on just yet for us to gauge what the industry response is.
Well, I look forward to hearing about it soon. The next question I might direct to David Houston. I see Albert has popped a short answer into the chat, but David, how systematic are the high concentrations of critical metals in different deposit types? Is it a consistent relationship, or is it influenced by a few critical metal-rich deposits that have more geochemical data?
I think in the fullness of time, a lot of these questions will be answered. I think, yes, that there are certain deposit types tend to be more enriched in critical minerals, in particular critical minerals, than others. I don't think all deposit types of that classification are necessarily going to be enriched in the critical minerals. As an example, germanium, we know it tends to be enriched in deposits like Mount Isa or HYC, and also some Mississippi Valley type deposits. It tends to not be enriched in VHMS deposits or skarn deposits, and that's a generality that we can see. There's going to be exceptions to all of that, but as a rule, you can say, well, I've got a deposit, an NVT deposit, and you can say, well, it's probably worthwhile having a look to see if there's germanium in that deposit. And there's a good chance there will be. So it gives you some general guidances, and there's going to be some there's going to be some exceptions, but it's just as a general guidance. The other thing is that we can actually use the mineral systems approach to look at other critical commodities, for example, potash, and we've demonstrated that you can use that to actually predict the location of potassium-rich brines. So there's a general sort of sense that you can use the general data that we've got to make some general, many generalities. But I think they're useful as a first approach, and you have to go in and look at the individual deposit in particular.
Thank you, David. And Chris Lawley, would you like to add anything to that?
No, I think David covered it pretty well.
No problem. Look, we've got a couple of questions in the chat about data modelling, uncertainty, and where these models might work better and where they might not work. So I might start with Chris and then maybe hand over to David. How does data modelling and the systems that we deal with gaps in the data sets and variable data density?
So one of the things that we prioritized as input into the models was our most continuous data sets. And so we sort of anticipated that that would be a risk. And so a lot of all of the results I've shown today were based on our national data sets. As we go forward with data sets that have more and more holes, that'll become more and more of an issue. And so we'll have to face that as time goes on. But there are multivariate imputation methods that are pretty good at dealing with small gaps. And for big gaps, it just means that we need to invest more in mineral system science.
Absolutely agree. David, would you like to add to that?
Well, it's a definite problem when you don't have data sets which cover everything. And the issue that you have is if you use partial data sets which are only partially cover regions, then you actually create biases in the final, or you have a potential for creating biases in the final product. And as a consequence, the analysis that Chris has done has only used fairly data sets which are uniform across the two of the three countries. And so there's a number of data sets which we haven't included, but could enhance the analysis, but it would be only limited to certain areas. And it's a matter of getting those data sets, together. So it is an issue, and unfortunately, I'm not technically in that sort of space, and so I'm going to have to bow out to Chris, other than those general comments that I've made.
Thank you, David. Anything to follow up, Chris? And Albert, I invite your opinion as well on this.
The only thing I'd add is sort of that undercover issue has turned out to be a real issue in Australia in particular, but also in Alaska. I think, especially with these data-driven methods, modeling both with the continuous geophysical data sets and then comparing that to models that are based on the geological data, I think that's an important approach, and that's something that we're trying to do, trying to sort of explore how important those regions undercover are to the final model results.
Yeah, I agree, Chris. Albert, did you want to add anything, particularly about how the deposit classification can help sort of level the playing field, if you like?
Well, I think the challenge is organizing data so it can be put into these models. We can generate criteria that have to be met for a system to operate, but sometimes those are readily mappable with existing data, and for other criteria they just aren't. So it's about trying to generate those coverages for criteria that are of key importance. And David and Chris touched on that. The one thing that the one-to-many relationships that exist between system types and the deposit types that occur within it that bears on prospectivity is in cases where you see one deposit type, one part of the anatomy of the system, the system's there. So there's some probability that the other parts of the system are present nearby. And that's one use of the classification scheme and prospectivity mapping.
Thanks, Albert. No, excellent point there. We have a question that I might direct to Tom. What is the next step for CIMI, and are there any policies in the US Congress that could help?
Next steps for CIMI, one of the things that we've been looking at are doing mineral resource assessments for certain commodity types or deposit types rather, and the clastic dominated sedimentary systems. And so that's one of the next steps that we've been we're contemplating, and actually contemplating is not the right way to put it. We've been working towards that. So we expect to see that coming up, and of course we'll be working collectively on joint efforts. I noticed some questions here, and I think this kind of relates to your question, Marina, about mine waste. And mine wastes are, I think, a logical area of collaboration between our surveys, and our countries have vast amounts of mine waste of different sorts at different localities, and we know that since many of the critical minerals occur as byproducts that were discarded during previous mining operations, that those waste deposits are potential sites for today of the economic recovery of some of these materials. And that's a logical area for our surveys to collaborate on in the future.
Thanks, Tom. I'm going to acknowledge a question here about making sure that we have very clever young earth scientists coming through the university and college systems so that we can continue doing this amazing work, not just into the near future, but into the long future. I won't hand that over to the panel, but I definitely acknowledge that's an issue around the world. And I think that critical minerals offers a really exciting opportunity for different technical skills to be developed with a real world application with our sustainable development goals. I'll just have a pop down here. So I might hand this one to David. In addition to mapping, is there any cross collaboration between your agencies also looking into environmental reclamation or impacts of mining?
Not at present, but just remember that we're just starting this this initiative, and so there's opportunities to move into other issues. One of the things which is critical, which is really important about the ore deposit database, is I think that actually can be used in an environmental sense, in that you can actually predict what sort of deleterious or other elements are present within the ores, and you can actually use that information. The other thing that you might be able to do is use the information from that data set to predict what might be present in ore waste. Like, for instance, there has been significant cobalt from the Mount Isa copper deposit. I think historically it had been recovered at one point, but more recently I believe it's gone to the tailings, and so there's an opportunity perhaps to use that information to predict what tailings or what mine waste might potentially contain critical minerals. And one of the things that we've had in discussions with industry is that they see the tailings and the mine waste as hazards, and they want to remove the hazards in some cases. And so if you can do that and make a little bit of money on the side, then that's useful. You're basically killing two stones, or killing two birds with one stone. So I think that there's the potential for a lot more collaboration. We've set up a baseline, and I know that each country, or at least Australia, and I think the GSC and also the USGS are talking about mine waste, and that's something that we collectively might be able to leverage the information that we've got into a more holistic response in that field and other fields.
Thank you, David. Would anybody else from the panel like to comment on that? Okay. There's a question, any rare earth deposits prospects in Mexico? Now, the answer is have a look at the criticalminerals.org website and you'll be able to see. The answer is yes. Are there any rare earth deposits yet to be discovered in the USA? And Albert, I invite you to comment on that.
Yes, as part of the Earth Mapping Resources Initiative, focus areas with potential for rare earths were outlined in Alaska and the conterminous US. And you can see those in Open File Report 2019-1023, and the URL is in the Q&A.
It is. Thank you, Albert. The next question I might pass to Chris Lawley. For international data, will this come from databases held by the GSC, USGS and GA, or will it come from other geological surveys?
Yeah, I think that's one of the things that we thought about initially when we started this work, was sort of what happens after our 3 surveys get together. We sort of envisioned from the very start that this could be a broader project. And I think that's the real advantage of starting with that discrete global grid system. It allows us to integrate data from anywhere in the world. And so starting from that, I think, yes, absolutely, we can incorporate data from other countries, and we're already doing that, from the satellite gravity data to sort of the global data sets for the lithosphere, asthenosphere boundary, to global data sets for the base of the continental crust. So we really are sort of reaching beyond our 3 surveys to get data.
Thank you. Now I invite you to pop your questions in. We've got about 7 minutes left. So if you would like to ask a question in this event, please pop your questions in. However, you'll be able to find our expert panel online through the relevant geological surveys, and they'd love for you to reach out to them and ask your question offline if this is a little bit too public for your question. They're also very much seeking feedback, so really appreciate your feedback. There's a question: is the data cube prepared for mineral prospective mapping available online? And I guess that's not the portal. Is that your data cube, Chris?
Yep. So right now we have a draft manuscript that we're working on through our 3 surveys, and we hope to sort of release the data with that manuscript. But the truth is, we'll probably release the data in multiple ways, both as the data cube and maybe potentially, as individual layers going forward. The exact way we're going to release this data in all its forms is not super clear at this point, but yes, the answer to your question is yes, we will be releasing the data cube.
Excellent. I have a question for Geneviève, and I'd like to ask, how soon will you be updating your critical minerals list? It looks like, we're all looking at the first run of critical minerals identification was a little while ago, and now we're seeing a greater explosion of requirements and needs. You released your list of critical minerals not long ago. Are you reviewing that and have plans to update yours?
Yeah, well, the list of critical minerals in Canada just got released in March, so it's recent. It came from a lot of consultation, and of course it will be ongoing. There's question about this list, but we're very, very pleased to see this list out there now, published, released. And yes, of course, it's going to be an ongoing work. As for the date for a refresher, well, since it's very recent, I don't expect a refresher very soon, but we'll see how it goes.
And Tom, how about your critical minerals list?
Our critical mineral lists, of course, these critical mineral lists are not static. The first one produced by the U.S. Came out in 2019, and earlier this year we released the methodology and a draft version of an updated critical minerals list. That's in the review process right now. I don't have a date that I can offer, but sometime later this year we should be coming out with an updated critical minerals list.
And Andrew, in Australia.
Thanks, Marina. So Australia does have a critical minerals list. But it's a little bit different to the others. It's based upon what other countries' critical minerals are, mostly. And there is moves afoot to develop a domestic critical minerals list that will be promulgated by the Critical Minerals Facilitation Office, which is embedded within the Australian government.
Thank you. I think we've got time for one more question, which I'm just, my computer's taking a moment. If we are successful in finding new critical mineral deposits, those elements may not be critical anymore. Will the portal have a life beyond the next decade or so? Chris?
Well, I think, that's a fair point in the sense that, what's critical changes with time. I think we'll always need resources from the earth, no matter how good recycling is. If you think about it, if we get better at building things, they will have longer lifespans and won't be available to recycle. So I think there's going to be a need for new resources going well into the future.
And Albert.
Yeah, I think the database has many uses, and our emphasis is critical minerals. It can also be used to identify elements that are environmentally sensitive. And as new devices require new elements that we aren't going after now, we're pretty much analyzing a good part of the periodic table. So we can adjust to changing times. So yeah, this hasn't been part of our repertoire because we just focused on the primary commodities. Now that in this high-tech world, we need to look at the whole periodic table for the foreseeable future.
Thank you, Albert. I agree. The mineral systems component of the portal will see this as a very long-lasting, useful tool. We've got a couple of minutes left. I wanted to thank all the audience for your attendance today. I wanted to thank you for your questions and answers. I want to thank the American Geoscience Institute for their hard work behind the scenes, and we look forward to working with you again. Of course, a round of applause for Thomas Crawford, Genevieve Murquet, Andrew Heap, Albert Hofstra, David Houston, Christopher Lawley. Thank you so much to our wonderful speakers. Thank you to Carol, who is also Carol Shanotta from Geoscience Australia, helping us with the moderation. Really appreciate your time and effort and your team's effort into providing this wonderful Critical Minerals Mapping Initiative Forum today. Thank you all for joining us.